Okay, hello there. Well, this is a video about my findings once more, and some talk about these digital measurement, not digital, analog measurement tools. This is ein Messuhr. Well, it's forgot the name of the thing. Okay, so first of all, my finds. Today I didn't spend a lot of money. I found one of these. Well, the price was really affordable, and this is some very hard rubber. It's probably very usable when adjusting workpieces on your machine and doing the installations and so forth. Let's see how it is. Not too costly, and it's a suitable size. Yeah. And well, it's a hammer. Another thing I found is this. You see, it is actually a tap wrench. So I haven't seen these in internet, and these are really something. I like the appearance of these. I have a few of these back home, and now I found a little one. I have bigger ones, and now I think I have the complete set. I have no idea who has been making these. They might be Eastern Germany stuff. Oh, there is a name. Aladdin. Sesame opener. Well, yeah, it might be Aladdin. Yeah, it's Aladdin. Very old anyway. Not older than me, but old, even though. Then I found out these, and these are really good condition, never used. These are 4.5 millimeters wide, then 100 millimeters in diameter, and they are very suitable for my milling machine. They were made in Switzerland, and the manufacturer name is there. It is Vaulorbe. Yeah. What do you see? So there was two of these, and now I will show you. These were originally, when I bought them, they were really nasty looking inside wax, so they really were probably not used. So I saw now a video about me taking the wax away and doing some cleanup for these. Okay, here is a new picture of one. These slitting saws were covered with wax and a lot of dirt. Well, here I'm peeling one of the saws, the other one I peeled earlier. These slitting saws were manufactured in Switzerland by a company named Vaulorbe. I believe they are quite accurate. Well, I haven't seen an inaccurate Swiss product yet. Then here I'm washing all dirt away using the brush which was given to me by my wife. Please use this. In Germany it's quite difficult to find good dish brushes. Everybody is using some soft equipment. Yeah, I shouldn't have been using the same sponge as I'm using to wash my potatoes. I have to trust this one now. So that was me cleaning up those slitting saws. These are special ones. They are so-called staggered teeth. They can eat the metal on the sides as well as on the top. So you can mill with them sideways too if you want to. Well, I don't. These are, well, very good for slots. And yes, and because they have a very wide gap here, there is a place for the cut metal to go into. So you can take quite deep cuts with these. Then I bought the small brother. This is 2 millimeter wide, and yeah, wait a minute, it's 8 centimeter in diameter, and this one is also staggered teeth. You can see it there, and it is well, it's small, and you don't go that deep with this one. If you go deep, it will clog up with and aluminium, for example. You don't. You want to use a blade with quite large space between the teeth. And then, as I was on it, I got also. This is also staggered teeth. And this one is 4 millimeters. The other ones were 4. No, this is not 4. No, yeah, it is 4. And I have no idea who has been manufacturing this. Wait a minute. There is a name. Oh. I cannot read it, but it is my assumption that this is a German-made blade. Then one more, and this one is the biggest one of these. Has no markings of the manufacturer, and it's not staggered, but well, it's really big. And furthermore, the profile of the teeth is I think that is 90 degrees. It could be a little bit less. No, it's 90. So you could mill some dovetails with this one. My milling machine has an articulating milling head, and this could be placed on an angle and do the milling. Well, yes, I would prefer this one if you compare this. Well, I don't know whether you can do the dovetails with this one, but at least you can do a 90-degree groove if you want. Okay. And then then there is these measuring instruments, and I now remember the name too. It's a dial indicator. So these are not from flea market. I found these from eBay. They are both German. The name is Käfer, means beetle. I don't know why they are called beetle, but they are called beetle. and gaffer, and they are considered to be quite good quality. And the first one is this is metric, and it can measure 30 millimeters. So it has quite a long range. And this one I intend to be put on my saddle on my lathe, so I can use it as the one-axis travel indicator. The other one is smaller in every aspect. It's quite small. It's also a gaffer, and if you can see, the accuracy is 1/1000th of a millimeter, and the measuring range is really small, only 2 millimeters. Well, this can be used to, well, if you want to indicate your piece on the lathe very accurately. My lathe is not that accurate. I don't benefit from that. But well, it's better to be more accurate. It's better that the tool you are using to measure is more accurate than the device you are using the measurement for. So, well, yeah. Well, 1/1000th of a millimeter. So the big numbers you see there, well, big is a very relative interpretation. So the big numbers, each number means 100 of a millimeter. Okay, these are now my finds today. And the second part of this video I'm going to talk about how do you keep these in your lathe. How do you attach these in your lathe? I have a certain antipathy against, I'm a little bit against all sorts of magnetic equipment in the lathe. They seem to magnetize everything there, and the swarf tends to stick onto very strange places, and these magnetic indicator stands, well, they are magnetic, they collect swarf, and it's very hard to keep them clean. And once you get some dirt under there, it's there. My preferred method is to create an indicator holder as a tool holder. It is it's used instead of your machining tools. You put it in the quick change tool post and do your measurements, and there you are. It's and it's not complex. It's nothing but complex. It's as you will see, it's really simple to do. So let us start with some drawings and some thoughts over these. Some people make this a very scientific subject. Really, it isn't any rocket science. It's really simple thing. One of the simplest tools you can make. Well, how to hold this one in your lathe? The problem is, of course, that if you have this in your magnetic holder, the Noga, which is quite famous, and some Swiss mates which are really expensive, but they are actually not very stable. They are really flexible, and every time you want to adjust this ring around, this, for example, is quite stiff. You end up the needle going all around the display, and it's not very comfortable to adjust this one. And furthermore, of course it's more flexible, more than one sense of the word. It's flexible in the way that you can put it in any angle towards your work, and yeah, it's flexible. But on the other hand, if you think about, if you have a 4-jaw chuck like I do, you always measure, if you have the chuck here. Oh yeah, well, I have a Chinese lathe, so my jaws might look like that. And then you have your workpiece here, and you almost always measure from this direction. Almost always. Well, this one is probably very suitable for that purpose, but I usually use the one which I have already installed, and it's a little bit, it has a shorter measuring range, and well, it's already there. Well, when you install these, if you use your tool post, here is the very nice tool post with the handle, and then you have probably a nut somewhere here. And now if you think about that, you would like to have it square to your work, and then you probably would like to have this point on the center line of your work. So it's not over the work, not under, but on the center line. So what I did, I just with a hacksaw I sawed a piece of hot rolled steel. So it's a square piece, which then sits on the tool post in a holder, and there is a hole there which this goes through like this, and then there is another hole for a screw here. Note, it's not a locking screw which would push against this surface. It's something that squeezes the hole down, because this is slit. So now if we turn the paper a little bit, this is okay. So if we think about the piece, I draw it very big here. So this is one direction, this is a picture from, so this is supposed that the your dial indicator goes this way. So in my case, this too, there is this hole which is 8 millimeters. And as it happens, it shouldn't be exactly 8 millimeters. It's better if it is a little bit oversized. So let's say it's 8 plus n millimeters. It's something like 8.1 millimeters would be nice. But when you use an ordinary drill, you will get automatically a little bit oversized hole. The next thing is that you need a hole which is from the, this is upside there, and this is towards you, and the back side, this is towards that direction through, is towards the chuck. So you need here inside a little bit of a countersink, then a hole, and then you need to slit the piece like this. You can slit it with a hacksaw, it's very suitable for that job. And then you need some threads down here. And then, as you can imagine, you take a screw and you just screw it in and tighten so this gap closes. It will tighten this hole well, I noticed that if you make it with an 8mm drill, it's just suitable. The tolerances are really suitable. The dial indicator goes there very easily, and when you tighten it, it stays in the hole. And this is very easy to do. It's nothing special equipment is required. Just an 8mm drill, something to rotate the drill, and then a screw, one screw, yes, and this in my case was M5. It has a suitable, this, if I don't mistakenly remember, if I remember it correctly, this one is about 8mm for M5. So you can actually do the countersinking with the same drill you drilled this hole. It leaves a solder here, which is not the best one for countersinking. Of course, it should be perpendicular, or whatever the word is. It should be very, that's of course the best one. Okay. Well, furthermore, if you want to be a little bit fancy, you can actually, this is again the chuck of the lathe, and then you just put your drill there. Put your drill in the chuck, and then you put your piece of material on your holder. Here is your holder, and then here is the actual tool holder with height adjustments and a little bit of screws. And then you put the piece of metal here, and you can do the boring in your lathe. This can be done with a hand drill, but I would suggest, in my case, I did this hole with in the lathe. It's 100 times more accurate than your hand drill, and probably more accurate than the average drill press in home shop. My drill press is so sloppy that, it's so sloppy. It's really sloppy. And so whenever I need to bore accurate holes which are accurately placed and are absolutely, sufficiently straight, I do them in a lathe. However, here is a warning. When you put your piece into this kind of configuration, you have again this nice setup here. When you push, you don't push the drill, you move the carriage this way, so it bores the hole. But you cannot use a lot of force for this one, because it tends to rotate this tool post this way. I don't like to tighten my things very tight. Yes, of course they are tight, but very tight, I mean very tight. So, I'm always really careful when I do things like this. They it can actually rotate. It will rotate if you push it too hard. So that's one thing about, and well, lathe is not designed to this kind of configuration. So this was one of my my way how to do this. What I consider to be a wrong way is that you again have this nice piece of steel here. Then you make a hole into here, goes through your piece, and then you put a set screw somewhere, like here on the side. Now, and then you think this is a nice idea, no slitting, you don't need to put the slot here, and you probably also think that it's you need when you do this kind of thing, when you do this kind of thing, you need to squeeze it like anything else. No, it's really easy. When you bore the hole with an 8mm drill, and if it is straight and not too much oversized, it will actually need very small force here to push these, because actually it will be bending here. This will become quite thin, of course, depending what is the dimensions here. In my case it's something like 12mm. No, it's more, it's 40, I believe. So then these are quite thin, and it will flex here, and it doesn't mark your dial indicator. This case, you have the indicator shaft here, and then you have, in the worst case, you have a pointed set screw like this. You screw it down. Well, I'm not very comfortable with this, because it will always mark this part of the thing. Even if it is hardened, there will be other kind of issues, because the hole is always a little bit sloppy if you drill it with 8mm drill. Well, if you ream it to exactly 8mm, it might be very difficult to put this one into the hole. That's also not a very good or nice thing. And furthermore, when it's sloppy and you put a set screw here, it's only, how would I explain it? This is the hole, and this is really exaggerated. Here comes the screw, and here is a little bit exaggerated the measuring instrument. So when you have the screw here, here's a gap. This is a gap, and then it will be resting in only one point here, and the other point is really a point in this side. It might wiggle a little bit. On my world, this is not a very good solution. It will mark your equipment, and it doesn't give you that good of a hold. This configuration, however, it's as easy to do. If you count the operations here, the hole, it's the same. The slitting, that's an extra. Well, just take your favorite hacksaw and make it. It doesn't. Yeah, this slot doesn't need to be accurate. No, it does not need to be very accurate. It's enough that there must be a slit, and that's it. And then one thread. The other one also has one thread. The only extra operations here are this countersink, which is actually optional. You don't need to do that. You can put it the hole to the surface and have your nut sitting on top of your thing. I just don't like that kind of things. I would like them to be under the surface, if it's possible. So this is not difficult to do. And what happens when we compare how it grabs the instrument? Now you have this round hole here with a slit, and then you have the flexible areas here and here. And now when you put this measuring instrument there, it will be touching here, here, in the back side, and also here. It will be touching the instrument not only in 2, not 3. If the design is really good, it will touching it all over. But it will anyway it will be spread all around the hole, and it's more stable, and it does not mark your instrument. The instrument is easy to get out of there if you need to do that, and yes, it's a really good solution. Okay. This one can be done in, I think, half an hour. If you want to make something fancy about this, harden it, for example, well, I wouldn't. But if you want, you can harden it, and you can make some joints to it, so it's like there is a joint, so you can swing it around, etc. Yeah, you can do that. Well, in my case, this is the dial indicator head, and I have also the other end of this this holder. The other end contains a dovetail, a very small dovetail. You can guess what is put in the other end. And there is also a slot, a little bit longer, and then we have a hole there. Its only function for the hole here is to make this joint flexible. Then we have this screw, the countersink here, and we have the threads down here, and here comes your test indicator. This one I made with a file. It's really easy to do. You just first make it like this, just a slot with your file, and then you take a triangle file and you file these. And when it's hot rolled steel, it's depending of your accuracy and depending on how nice you want it to look out, it will take something this end something like half an hour to up to, well, maybe 3 hours if you really want to make it a nice one. So yeah, okay. So this was about this week. Yeah, and well, no sampling content. I'm very sorry about this. Well, Christmas is approaching, and then I can get you real material out of my machine. And well, till next week, have fun!